Hello, welcome back to Physical Meteorology. This is Lesson 6 and 7, Atmospheric Density and Ideal Gas Law for Dry Air. First, we begin with air density. We define density as mass per unit volume, or ρ is equal to mv. Therefore, generally speaking, air density is just the mass of air divided by the volume that it occupies. And we usually measure density in terms of kilogram per cubic meter. And in the atmosphere, gas that is less dense has a lower concentration of molecules per volume than a denser gas. And these gases with low density will tend to rise or float in the air compared to gases with high density, which will tend to sink. And we will learn a lot of this, and you are always introduced about air parcels sinking and rising. And one of the reasons why it does is because of the density of that air parcel. Okay. Now, what affects air density? What are the factors that makes it denser or less dense? So we have here air density varies with the relative humidity, or how humid your air is, and your temperature and your pressure. Your temperature, of course, is a measure of the internal molecular energy of a system, and therefore we are measuring here how your cold air and hot air behaves. As what you can see here, cold air is usually denser than hot air. The main reason is because air particles decreases as they are heated. And why is that? Suppose that this box here is hindi siya totally closed. It's not an enclosed system, and that's what happens mostly in the atmosphere. So therefore, there is free space. Ngayon, if they tend to move around faster than cold air, so ito, kapag nag-bounce siya dito and nag-bounce siya dun sa mga walls, they tend to escape the box. So kung mapapansin niyo sa cold air, mas dikit-dikit sila because they don't move that fast. But on hotter airs, or in hot parcels, they tend to move faster, and therefore causes them to escape the system or this box. We can conclude that air parcels, or air that has higher temperatures, is less dense than the cold air, where the particles are close together and doesn't escape much into that certain system. For air pressure, kabaliktaran yung nangyayari, because increasing the pressure increases the density as well. Think of what happens when you press down the handle of a bicycle pump. So parang ganito rin sa situation na to. The air becomes compressed and the density increases as pressure increases. So directly proportional si pressure at si density. Therefore, also, kapag makikita nyo sa atmosphere, yung mga ganitong types ng illustrations usually shows yung sa baba, mapapansin nyo na higher yung density, and then higher din yung pressure at that point, and it decreases as it goes higher into the atmosphere. And also, one of the factors that affect your density is your humidity. And we are often told, and we are often confused if dry air is denser than moist air, or is it the other way around. Usually, iisipin natin that the more moist the air in the atmosphere is, the denser it will be, but it is not the case. Actually, dry air is denser than moist air. And to further investigate this, we need to recall Avogadro's law that says that at an equal volume of gas at same temperature and pressure, there will be equal number of molecules in a certain system. So kunyari ito yung system mo, and at same temperature and pressure, equal yung gases na nandyan. And dito sa isang gas, makikita mo na 0% yung humidity, therefore dry yung air niya dyan. And dito sa isa is 100% yung humidity, therefore it's very saturated. But the mass is different. And actually, kapag doon sa mas higher yung humidity, mas mababa yung mass niya kaysa doon sa merong mass na doon sa 0% yung humidity or yung dry yung air. Which means, it directly translates na mas denser si dry air kaysa sa kay moist air kasi mas magaan siya yung moist air. And why is that? We need to look at the number of molecules. Kasi sabi natin kanina sa Avogadro's law na sa isang system, kapag equal yung temperature and pressure, kailangan equal yung number ng molecules. So, kung meron kang dry air and moisture, nag-start ka maglagay ng moisture doon, ibig sabihin, parehas pa rin yung number, but yung water vapor molecules mo, kasi let's also recall pala that in a system na dry yung air, therefore, ang laman lang ng system na yan ay nitrogen, oxygen, and also trace gases na nagko-constitute lang naman sa 1%. So, wag na muna natin siyang pakialaman. Let's focus on nitrogen and oxygen. Nitrogen has a molecular weight of 14 grams per mole. 14 grams per mole. And your oxygen constitutes to 16. Your oxygen has a molar mass of 16 grams per mole. But then, your nitrogen and oxygen comes in pairs, and therefore, this becomes 28 and 32. So, kung meron ka dito na mga nitrogen particles at oxygen particles, so ito yung bubuo sa molar mass mo ng isang parcel. However, pag nag-try ka mag-introduce ng water vapor, ang molar mass niya ay 18, which gives you a molar mass that is lighter than the other two. And what happens is, kapag pumasok siya dito sa system, papaalisin niya yung ibang mga particles ng either ng nitrogen or oxygen. So, iki-kick out niya yan dun sa system. Kasi dahil nga sa Avogadro's law na kailangan same pa rin yung number ng molecule. So, kailangan niyang palitan yung molecules ng either nitrogen or oxygen doon sa system. And when that happens, mas gagaan yung air parcel na yon. Kasi nga, mas magaan si water vapor compared to your nitrogen and oxygen. And that is the very idea of why dry air is denser than your moist air. Okay? So, I hope that's clear. I also included a separate video on that, kung medyo magulo pa yung explanation ko. So, please head on to your Google Classroom. Next, we now go to the density from the ideal gas law. So, paano ba natin kino-compute yung density from the ideal gas law? So, we know that your ideal gas law can be written as PV is equal to nRT. And we also know that your density or rho is equal to, wait lang, let's change the marker and make it bigger. Density is equal to mv. And your n, itong n mo dito, can also be written as mass over molar mass. And so, for us to arrive at this answer, we rewrite this expression to PV is equal to M over M RT, which gives us PM over RT is equal to MV, or your density, which gives you this expression. So that's how you derive your density from the ideal gas law. Alright? Now, air density and your average molar mass. Air density is also dependent on the average molar mass of a parcel, which means that the molar mass depends on the atmospheric composition and just the sum of the fraction of each type of molecule times the molar mass of each molecule constituent. Ang ibig lang sabihin nito, yung density mo is equal doon sa molar mass ng mga kung ano yung nasa atmosphere. So, kagaya ng ginawa natin kanina, kung may nitrogen, merong oxygen, at kung meron kang water vapor, doon nagde-depend yung iyong density ng air. So, it really matters kung moist yung air or dry your air, or dry yung air mo, or also kung meron kang system na iba yung composition ng mga gases na nandoon. Okay, so ito lang yung gustong sabihin niyan, na nagdedepende siya dun sa mga molar masses ng iba't ibang constituents ng atmosphere mo. So, with that, I want to pose this question. I want you to calculate the density of dry air using the ideal gas law. So, okay. I need you to submit that today before or not later than 5 p.m. This will be a very napaka-short lang ng computation na to. Ipopost ko yung assignment sa Google Classroom ng 4 p.m. You can start doing it now and post it 4 p.m. And I'm doing this because I want to test who are really watching and checking the things that I upload on Google Classroom. So those who didn't watch or even read the PDF that I'll be uploading, therefore hindi niya magagawa yung assignment na to. Or if you are really, kung mabait ka, so sasabihan mo yung mga kaklase mo na, hoy, may pinapagawa si madam. So yon, I want you to calculate the density of dry air using the ideal gas law. So that's assignment number 1. Now we go to the dry air. So, ano bang meron sa dry air at ano pa yung kailangan nating malaman sa kanya? Usually, for dry air, we also want to know the R star or yung RD na ginamit na natin sa isang equation natin. Your RD is your dry gas constant for dry air. And how do we get the dry gas constant? So, saan siya galing? Recall from the previous equation, this is your ideal gas law. Pwede rin siyang isulat sa ganitong way na PD is equal to rho D, RD, and T. And paano tayo nag-arrive dun sa RD is equal to R star over M ng dry air? I want you also to try to derive this equation. Where did this come from? Galing sa equation na to. And clue lang na pwede kong ibigay is kung ano yung, you also need to remember that your density is equal to MP dry air R star T. So with that, paano nag-arrive sa ganitong equation yung gas constant for dry air, which gives us a final a constant value of 287 joules kilogram per Kelvin. Okay? Note that P must be in pascals and T must be in Kelvin. Okay? I think that's it for this video. Please answer the questions. I will be posting the assignments 4 p.m. today. Maraming salamat and see you on the next video. Bye!